Hello colleagues, my name is Alexander Zelenin. I am a software engineer with more than 15 years of experience. Today we will try to solve Microsoft Online Assessment on LeetCode with JavaScript. It will require to solve two questions in lines, and we will have 1 hour for both of them. First of all, goal is to solve them, and second goal is to solve in optimal way. If there will be enough time, I will try to draw solution and explain them maximum as possible. But we'll need to keep good pace. So let's start and see what will be what we have here. So first task, given an array with an object colored red, white or blue, sort them in place so the object of the same color are adjusted with the colors in order red, white and blue. Here we will use the integers 0, 1 and 2 to represent colors. You're not supposed to use library sort function for this problem. So we'll need to create our own library or something like that. Okay. Since we have just 3 colors, we can create dictionary and just count how many items we have and to create array from the scratch. Looks like this is faster solution, and it will have space complexity 01 and time complexity of OM, since we will need to go once through initial array and second time through recreating new array. But for creating new array, we originally will have additional ON for memory. So it will be ON, which is nice since optimal sorting algorithm has n log n, and we are faster than that in this specific case. Let's see what we have in additional here. Rather straightforward solution is a 2-pass algorithm using counting sort. 1-pass algorithm. So yeah, we exactly with that. So the idea here is, let me draw this one quickly. Since this task is easy, I will have time to explain. We will count every same number. So we'll have like 2, 2, 0. Let me change color. 0, 2. So like this. And for last one will be like 1, again 2. We'll create an array from 0 to 2 and we'll store the exact value on index. So and after this we will just create a new array from the last one to first one. So there will be like 0, 0, 1, 1, 2, 2. So let's go to write code and try to do it without any errors. Also, we need to think about possible cases. For example, what if we doesn't get anything? So, for example, if num's length is 0, we expect that we getting array here, like array, but it can be empty. So we will just return empty array just instantly. So we'll create some structure No, not structure. Let's name it just colors count. It will be array of 3 elements, right? 0, 1 and 2, 3 elements. Now we go through nums. We have num, and we will increase color count num by 1. I did not remember initially array is nulls, so we will need to make all of them 0. So let's set like default value of 0. Maybe there is some shorthand for this, but that's fine. Anyway, it doesn't change complexity or anything. So we had to count them. Now we can go through colors and create output array. So it will be same for each. And we will have 2 of them, 2 of arguments here. First will be count, and second will be like index, which represent color, so which represent number itself. So number, and let's create result array, return result, and result, and we will push our number n times. So we need to repeat this n times. So let's create a loop from 1 to count. We will repeat this push. So let's see. We had cover case when we have 0 elements. We had if doesn't have some colors, for example, there will be just 1 and 2 and no zeros. We will go through this, but this will be empty, so since count will be 0 and 0 is not like this condition will be not accepted. So let's try to run code and see what we have here. And by some reason the output is not the proper one. Why it's the same? Colors count. Let's take a look what we have here. Cancel log. Colors count. Not a number by some reason. Okay. Why is map doesn't work? Very strange. So as I had presumed initially, I make some mistake here with like 3 empty object. Why we cannot map them? Okay, it doesn't matter too much. we can do it like this, 0, 0, 0. Since we have just 3 elements, this approach should be fine for us, right? So we have 2, 2, 2. Then we go through our array. We have count and we have number itself, right? We push the number count times. We push it to result. Why it doesn't work? Very strange. Count number. So two times 0, 2 times 1, and 2 times 2. We need to sort them in place, so we need to modify initial array, right? Okay. Fine, it doesn't change anything. We can modify yep, we need to modify nums and we don't need to return anything. Fine. Let's make like global index then. Index from 0. We will increase this index and we will set like nums index equal number, like this. So it is important to read conditions that we have here in description and so on. Otherwise, it's possible to have mistakes like this. So in this case, if nums is empty, we don't need to return anything. We just return, since we working only with the value with the argument itself only. So we just rewrite it and that's all done. So we can submit our code and it works. Let's it's possible to see some result here? No? Okay, so let's go for next question then and see what we have here. Given a non-negative integer, so 0 or positive integer represented as a string, remove k digits from the number so that new number is the smallest possible. The length of num is less than 10,002 and will be greater or equal to k. The given num does not contain any leading theirs. So let's take a look at this example. We can remove 3 digits. All right. Okay. So in the end, we're creating something like that. So the main idea is to remove greatest numbers on the left side. since with this approach we'll have lower possible. So we need to get the smallest number. Okay. For this one, if we remove 1, the leading 0 also will disappear. We'll have just 200. So, for example, if we will have 2 here, we'll able to remove 1 and 2, and we will have like 0. Let's think what we can do here. So let's try to design something and to understand the problem a bit better. So in case of we have 3 numbers, we'll try to remove this one, and this one. What if we'll have 2 numbers? We'll try to remove this one and this one, right? What if we have just 1 number? We are still removing 4. What if we'll have 4 numbers? 4 numbers. For 4 numbers, we'll try to remove this one. But if there will be something like 1, 0, we can count it as a 10, right? So we'll able to remove the block of, but only if it's leading 1. So let's think about some interesting case when we have something like 1, 1, 0, 0, 0, 99. So in this case, and for example, we need to remove just 1 number. If we need to remove just 1 number, it will be reasonable to remove maybe this one, just 9. So we will remove like 90, because if we, or this one. No, I think this one will give us a better result. So we will end up with something like 1, 0, 0, 0, 99 versus 1, 1, 0, 0, 0, 9, right? So we need to remove items from the left part, but so there is no difference which one is to delete. Okay, this question looks like a bit tricky, so it's not as easy as previous one. Previous one was super obvious, and this one is harder. But that's interesting, and we have enough time to think about this one. So what is interesting with previous one, that we try to remove, if we will remove the first number, original result will increase instead of decrease. So and for example, if we have 2 numbers to remove, we need to remove this and this, so we will end up with just 99. So first of all, a number with leading zeros is counted as best option. So we have something like this. We'll count this as best option. I think we need to remove numbers one by one. So we need to design an algorithm how to remove just one number, the best one, to achieve best possible result. So we have some edge case. Looks like only with the last two numbers. So we will need to choose delete only first or second number. That's my assumption. If second number is greater than the first one, then we're removing second one. Otherwise, we remove first one. Then we remove zeros if we got some of them. And repeat this operation until we doesn't have anything to remove. Okay, let's try with this approach and see what we will have, and then we'll reiterate when we will see that something is wrong. So I just want to start writing some code to see how it will work. So originally I want to, what if we remove all the numbers? We have exactly this case, left with nothing. So let's start with this condition. If k is greater or equal, also we need to convert it to string. So let num string, it will be num to string. So if k greater or equal, we return 0 instantly. So also we can make it recursive to call itself and by removing just one number. So we will need to also remove leading zeros, but we will automatically remove them when we will return value. So we can return as integer, like return parse int, like this. So we'll modify this one by removing required one. Also maybe we can make array. It will be easier. So yep, let's make array and just to have indexes. But with string we also have indexes, right? Okay, let's skip it for now. So we need to skip num str 0 with num str 1. And the second thing is, but yeah, if the second number is 0, it doesn't matter anything, right? No, originally it matter. If we have something like 1 0 9 1 1, for example, and we're removing 1, we left with 9 1 1. But if we remove 9, we remove with something greater. Yeah, okay, looks like it doesn't matter. So we need to just compare the first two of them. So The first symbol should be greater or equal, and if it greater or equal, we will modify it that way that we'll have just substring from the second symbol. Substring from a second symbol. Otherwise, we will have something similar, but we will keep the first symbol and start with the third one, right? But it will also work only. Also, there should be another case. If k is 0, then we just remove number. Let's do it like this. If k is 0, then we just return number. If we have a small number, for example, with just 2 digits, then will doesn't have anything like that. I didn't remember exactly what happens if we try to get a substring of something that not existed. So let's just take a look. Substring. So for example, we're starting from 1. What if we're starting with 5? It will be empty. So we doesn't have any problems with this. Will doesn't go like out of boundaries. First symbol is always exist. So we just choose which symbol to remove, first or second one. And after this, we can check if k is greater than 1, greater than 0, sorry. Then we will call same function. We will provide so let's create something like result. So we will provide our result and k minus 1. So if we have, so it's greater than 1, right? So if we have 2, then we need to have just 1. We already will return this. So let's try to run and see what we'll have here. So for initial case, we have exactly what is expected. Let's try to have some other conditions, like with single number. So we remove 4 in this case, which is fine. Let's try to remove like more numbers. We left with just 19. Is it proper one? Is it proper answer? We can left with just 11 in this case. Right? So we had found quickly the case that our algorithm doesn't count. So let's see. Can I select place value from here? So let's try with these numbers and try to understand what goes wrong. So we start with removing first or second one. So we remove the second one, we remove this one, we remove this one, we remove this one, and we're left with 119. In this case, So this case happens only with 3 digits numbers, right? Or not? Or no? So in this case, we need to compare our options with the last number also. Yeah, I think this case happened only when we go to 2 digits number. So we need to compare like the last one with the middle one in this case. It's same when we have 2 numbers, like for example 98. But for 98 it's easy, we will remove 9. For 89 we again remove the largest one, which is this one. But if we have 819 with 819 we need to remove what if we have in the end some combination of numbers like 9 9 and in start we have 1 1. All right, we want to remove 2 numbers, so we will end up with 2 total numbers, and the optimal solution will be to left with 11, and this is greater than 3 digits originally. So what does it mean? It means that we need to count the last one, but also what if we have like 1099? A lot of tricks come out, right? Since in this case the first number should be like 1, and as I told initially, if we have after the first number 0, then it's priority to remove the first one. So we need to somehow use this k. So originally we have a window of just 2 numbers, right? If we have 2, then we have additional window of another 2 ones. So, but I think we can work with just last one. So it doesn't change anything if we'll remove a number from middle. At least I think it for now like this. So let's increase our conditions. So if the second symbol is 0, then we anyway go with removing the first symbol, since we want to remove 0 also. It will be removed with parsing integer. But in this case, Let me think for a few seconds. So we have length. Okay, so for example, it's 3. It's 3. We remove 2 digits, which is our window, and we also remove k, which is and what I want to achieve by this. So 2 plus k should be greater than half of array, half of number, but I can be wrong here. So let's think with some larger numbers, like what if we will have something like 1 1 1 1 1 9 9 9. From what point we will need to remove the 9s instead of 1s? Let's see. If we have from 1 second. So if we have just one number, it will be better to remove the first one, right? So we will end up with like this one. Since if we will remove 9, we will end up with which is better. Okay. Like, what is the difference between the first and last one? There is no difference. Both of them reduce the number, but on left side we have chance of these zeros, which give us opportunity to remove like more numbers. That's why from left we have like more priority, since we can have something like more than 9, like 10 or 100. So we need to compare with the right side the same way that we compare with the second one, and we should do it all the time, right? Or not, or no? What if we have something like 1 1 0 1 1 9 9 9? So for first step, it will be reasonable to, if we have just one number, it will be reasonable to remove 9. But if we have two numbers, then it will be reasonable to remove from the left. So let's try to do it this way. We will search for the first 0 and see how many, like, can we remove until the 0 numbers, and if we can, then we will do exactly this step, and then we will repeat this operation with what is left and so on, by comparing by comparing all options we have, and we will have like 3 of these options. I have no idea what to do with it, so let's comment it for now. Let's see closest 0. So 0 index will be index of 0. So if we have something like this, we'll have the index of 2, right? And our k is 2. So if our k is greater or equal than our index, if our k greater or equal than 0 index, then we will do and otherwise something else. Then we will remove exactly the number that required. We will remove we'll remove the digits until we go till this 0, and instead of making k minus 1, we'll modify it like for bigger distance. So we'll modify k here in place also. So we will start with substring from 0 indexes. It doesn't matter, this 0 already doesn't matter anything. And we need to modify k. We will remove exactly 0 index from here. Okay. Looks good. So yeah, I will prefer to call remove digits right now with our new k. Okay, like this. So we handle the case when we have couple of numbers. Now we need to compare numbers properly. So for example, in this case, we want to, if we want to remove just one number, we want to remove 9. Since we will left with just 11 thousandths instead of again 11 thousandths is worse than 10,009. Maybe we need to compare k numbers from the start and from the end. Okay, let's think a bit more about this one. In this case, if we will have 2, we will prefer to remove this one and we will left with just 9. For 3, 1, we will remove all of them and that's fine. What if we have something... which color to choose? Let's go with black. If we have something like 1, 1, 1, 2, 2, 3, 3, 9, 9, 9. Okay, so what we can do with that? First of all, we can compare two numbers, like 1 1 2 2 3 3 9 9 9. This one or this one. So removing 9 in this case better, right? Since we go with a lower number. But in this case we were able to, so we need to compare them with some combinations. It looks super easy, but it's not as easy as it looks like. So what if we'll have something like 11, like 0 0. So let's start with something smaller like this. We have options to make it like 1099. Oh. Or 1109. Right? So how we can compare it? In this case, removing the first number is better. Okay, I think I got an idea. We need to check how removing number will affect the result. So if we have 1 on so a few more examples. 1 1 1 9 9. In this case, we will have options like 1 1 9 9 and 1 1 1 9. In all these cases, we remove just one digit. Maybe we can compare somehow by two numbers. No, doesn't work. Something like this doesn't work. Oh, I was thinking that we have a lot of time, but right now I don't think that we have a lot of time. I'm not sure that I will able to solve this in next 11 minutes. But let's see. Okay. What if we will have another number like 11 to 99? In this case, we're able to have 1299 or 1129. And 1129 is lower. So we comparing like one part of number with another part of number. So we have 1, 1, 2. So let's see where we have same parts. Here, here, here. I have no idea why I tried to select them, but just want to see what combinations it's possible to have here. Is 2 affect anything? Like from what moment removing the first number will be like here we remove the last one, here we remove the first one, and this one is better because this number is lower than next one. And if we'll have 1, 3, 2, 9, 9, then we'll have options like 3, 2, 9, 9, I had modified the proper one or not? I'm not sure yet. 1, 2. Oh. There should be some simplest approach that can help us to solve this. So let's think. So sometimes it's better to remove the second number, right? So, okay, easiest approach is to, first of all, we go with this thing with 0 that I had told. Then we making all possible numbers with without any other number. Like we remove just one, then compare all of them, find the smallest number, repeat. Okay, done, fine. Maybe let's do like this. I doesn't like this because there will be like a lot of combination. This can lead to timeout. But I'm not sure that I will able to make any other approach. So let's go with this one. So let's create array of options. Then we go through every digits in our string. So for let I equal 0, while I is less than length, we increase I by 1. Then we put two options, the number without the one digit. So we'll have num str from 0 to I, then we skip one number and substring, of course, substring. So we took like 0 from start, we remove the first number and making from I plus 1 to an end, to the end. Substring, we make parse int 10. Okay, so we create all the options. We sort these options. Sort A, B, A minus B. Okay, and then we took the smallest one. So it will be options 0 after sorting. So our result will be option 0. And we run it one more time. So let's see, it doesn't work at all. And that's not good, not good. Let's try with just one initially. I want to check what we have in options right now. So it doesn't go here. If 0 index doesn't equal -1 and okay. So let's try to have options with 5, the one that we start initially. Then we have an options of 1109, 11091, 2, just 9. So okay, looks good to me. Let's submit. We fail at okay, it's just expect the string. Fine. We can return to string. Totally fine for me. So where we also have any other returns. So it expect to get 0. So it's already a string. So let's try to resubmit. And I just need to add the toString to all returns. toString. Why? So we have a lot of numbers here. I copy our code. And we need to remove a lot of them. I'm not sure why it fails. It obviously it have not 1000 but less numbers. I mean there is much more than 1000. But our output is 0. So it looks like by some reason so we found a 0. Okay. I found an error. Found an error. Let's go to this test case. I think the error that here, when we go to the lowest options with less k, we returning like if k is equal to 0, we return our original number, but that's fine, right? So we had failed. That's okay, happens sometimes. Let's just figure it out what was wrong with the second algorithm. This was an optimal one, and will be better if we'll start with like an optimal one, since the task originally was harder, much harder than I assume initially. So we make a lot of numbers, we sort them, we took the smallest one. Okay, let's resubmit just to check the input data. Can I use this test case here as custom one? Yes, I can. Just want to confirm where it happens. So is it happens? Yes. Just want to see what is num length. So let's have k and num length all the time. So we have k of 1000 and num strange of 10,001. When we go just for next step, why it so first of all, our function ran only once. Second thing, if so we found 0, then we remove this 0, and we remove from k. Let's have also here 0 found. So we have 0 index, we have our k. All right. Also, let's see what is current length of string. So what I doesn't like that I cannot change the size of console. That's not good, but okay. So we found a 0. We have index of 24. So we try to remove 24 from k, right? Let me just to see like 2 of them. It doesn't matter that we are making like passing number here, since we anyway make 2 string here, so it doesn't matter anything, right? And also maybe we don't need to make a parseInt every time. We will need to parseInt only here. Okay. So just unnecessary step. We make parseInt just to have a normal comparison of numbers. Also for that big number, that was originally obvious. It not under integer, so I cannot just sort them like I do, so it will just doesn't work. That's all. So that's algorithm I was thinking initially is not stable one. Okay. Also looks like here is one of mistakes, that if we have a couple of zeros, yeah, that was the reason why I make a parseInt every time to remove zeros, to remove all the zeros, right? All leading zeros. So let's also write the string itself. Yes, it will be big one, but fine. Just want to see what happens here. We have 0, but that's fine. The 0 will be removed. That's not a problem. Like, but why? What happens on next step? We remove 24. We call to remove digits one more time. Let's do something like that to show the calls itself. So we call with 1000, then we call with 976. Okay, but when we call it with 976, our number already very small one, and it's small one because of parseInt and it's not under integer. Okay, let me think. We can use big math here to use big numbers, we need to use some library. So leetcode big numbers javascript. Okay, I'm not sure that we will find this on time. We already spent a lot of time, so the algorithm of going through all of them was like not stable, because we have big numbers that not under integers, and it's not safe way to convert them, sort them, and so on. So we had failed this one. I will try to think more about exactly this task, and will prepare for next video some solution for this one. Thank you for watching. Set like, subscribe. Have a nice day.